Welcome to Introduction to Excel. So, spreadsheets. Excel is just an application that handles how spreadsheets are used for data analysis, I suppose. Anyway, spreadsheets provide a simple graphical way of working with numerical data. So that means Excel is an application that allows you to handle spreadsheets. Ding. The potential use includes all those items listed here. So Excel can be used for various things, actually. And when you do actually work in a place, a lot of data will be stored in the form of Excel because Excel do provide you with various functionalities, such as analyzing the data, visualizing it, and so forth. So Excel is a great tool that you can use. So why would you use spreadsheets and what can you achieve with it? Have a think. You can pause too. Well, they are powerful, simple to use, allow quick prototyping of models and analysis. That means you can quickly build and evaluate data that you get, and Excel will help you analyze the data and produce some visualization that can summarize the meaning of the data very quickly. It can also be used to solve equations with one independent variable. Okay? Allows summarization and visualization of the data as described before. And lastly, allows different scenarios or models to be built and simulated. So it is very easy to change variables in Excel to see how it affects your outputs. Quite straightforward and easily through visualization as well. So let's have a look at an example. Yeah. So here's an example of some data, which is based on temperature. Okay. Can you quickly tell me which date has the highest temperature and which date has the lowest temperature? Did you get the answer? Yep. It may be possible to do that in time because our data only has roughly about 13 rows. But if this data was, say, 1,000 rows or even more, then it's going to be very tedious to locate which time of period was very cold or very hot. Instead, we can use visualization, such as presented here. It shows us quickly that which date was highest and also the lowest, such as here, the highest, and here, the lowest. Okay. So in Microsoft Excel, an individual sheet is called a worksheet. Okay. Multiple worksheets are collected into a file, which is called a workbook. A worksheet contains a 2D grid, as shown here, labeled by numbers per row and alphabet letters per column. If we do run out of alphabet letters to use as we move along the column, then you will go back to A and then add another letter to start with. So it's going to go all the way down to Z, and then it's going to be starting with A, and then continue onwards. Okay? A worksheet consists of cells. So each block is called a cell. It has a unique address represented by the column and the row. Okay, so for instance, our very first location, the block up here, will be A1, and this highlighted cell down here will be E3. I should be pointing over here. A1, E3. Okay. The cell currently in use is called an active cell, which is outlined. Okay, so let's have a quick look. By the way, this particular Excel workbook is available for you to use from our quiz server. Okay, so do download it as we will be using this in the next few slides. So here the active cell is A1. Let's zoom in. Ooh. Okay. And if I click somewhere else, for instance, C6, now C6 is an active cell. Okay. Continue. So this is a quick representation of each of the Excel components that you can use. So as shown before, the selected cell is an active cell. It has a name, got the column letters, row numbers, etc. Okay, so you can try to remember those in your own time. So let's have a look at cells, values, and formulas. A cell may be empty or may contain a value such as 3.2. Okay, so let's do that. We're going to add 3.2 up here. So you can see that the value inside gets displayed in the cell, as well as this formula bar here. Okay, so here later you can edit the value, which we'll see shortly. Okay, also you can put other things such as, let's put the 3rd of April 2018. Then it automatically interpret that as a date. So this particular cell has been formatted as a date representation. So you can see the value inside the formula bar as what we typed in, but the way it's represented in the cell may depending on how you want to display it. Okay? We'll look at it more closely later. Of course, you can type in formulas, and all formulas will start with an equal sign. So in this time, equal sign sum 3, 6, and 9. And after that, you hit an enter. This will display me a value, which means a formula has been interpreted, calculate the value that it's supposed to do, and then display the value that it calculated. Okay. So in this instance, you can see in the formula bar is the formula that we've typed in is the sum 369, but inside the active cell that we selected, it shows you the final value. Text values may be used simply as labels, for instance, number. Okay. So these may not be used in calculations, but only to provide descriptive information, which we'll see later on. Formulas start with an equal symbol, equal. Oh, yeah. Okay. So let's have a look at some data formats. The data format of a cell determines how it is displayed. So we have seen before that we typed in a date format with a full year, and then it got shortened because the way it's represented is different set by Excel. Okay, but we can always change this. A single number such as 0.01 could be displayed as a number, a percentage, a time, a number to 4 decimal places, and so forth. Okay, so let's have a look at that. 0.1 by default will just show as 0.1. So that's the number format, which is shown here. You can change the format here. Okay, so now let's change to percentage, which is down here. So by changing this, it's now 10%. Oh, I should have used 0.01. Nevertheless, so I can always change the format. Next, we will select time. Okay, so 0.1 is equivalent to 2:24 a.m. Okay, and finally, let's change this back to a number value, 0.1. And we're going to add some more decimal points. So here you can see increase decimal place and decrease decimal. We can use this to change how many decimal points are represented in this particular cell. Okay. So these different formats do not change the underlying value in the cell, just the way it's displayed. Okay. So let's have a look at an example. So we have some values that have been used to calculate the mean values for science and engineering, science only, and PCM. Okay. And the mean values have been shortened to a single decimal point, but in actual value, they may have more decimal points than what you see. Okay. So here's a, oh, sliding too far. So this is in your worksheet again. So the values calculated are down here. Okay, so let's just copy. Oh, not good. Okay, so what we're going to do is copy exactly the same formula on the next slide, on the next cell, and then expand the formula. Okay, so in here, average A1 to A10, we're going to do exactly the same. Average A1 to A10. Okay, science is B1 to B10, because average B1 to B10, and the last one is C, okay, equals average C1 to C10. And you can see that the values, because we did not specify the decimal points, it's going to display as many as it can fit inside the cell. So this means if I change the width of the cell, the number of displayed decimal points will change with it unless I specify to do so. Okay? So if I increase it again, then it's going to give me an exact value if it can fit inside the width of the cell. And to see the formula only, okay, we can press Control and this squiggly line at the top, or that tiny quotation mark, which will show me quickly the formula that is inside the cell being used. So if you want to check what kind of formula is inside the cell quickly, just press Control dot. Okay. So formulas express a calculation made up of functions, numbers, and references to cells or ranges, as we've seen with the averages. For instance, average between B1 to B10 plus 3.0 times standard deviations of B1 to B10. Well, try this yourself and calculate the value. So what is the value? You can pause. Okay, so let's write down the calculation here. Equals average B1 to B10, okay, plus 3.0 times standard deviation of B1 to B10. Okay. Oh, I got the formula wrong. Why is there 18 to 18? Okay, standard deviation B1 to B10. So the value you get is 105.475. So this means you can combine different functions in the formula with values and cell references all together. Okay. And in Excel, a cell referencing is relative references, which means you can copy and paste a cell reference from one cell to the other, and it will update automatically how you set it to be. Okay. So for instance, a cell reference consists of row and column label, for example, B1, like over here. So let's create that in our sheet. Okay, so delete everything here. Inside C2, we're going to say equals B1. Okay, so this means whatever I type in B, it's going to appear in C2. Okay, this is considered to be a reference to a cell relative to the cell in which the formula is contained. Okay, so you can do a lot of things with this. If the cell C5 contains a reference to cell C4, then this essentially means the cell above the current cell. B3 contains a cell reference to C4, then the cell one below and one to the right of the current cell. And what we can do is copy and paste this, and it's going to change, right? So let's try this. Copy B16 into C16 and see what happens. Okay, B16. So let's get rid of the formulas everywhere. We're going to copy this into C16. Ooh, we get a division error by zero, division by zero error. Okay, Why did this happen? Let's have a look at the contents of the cell. So in B16, it contains C1 to C10, but in C16, it contains D1 to D10, which means the range has moved by one column. When we moved the formulas from B to C, the reference moved from C to D. Okay? So if you don't want things to change, that means you need to use an absolute reference made by prepending a $sign to the column and row labels. For instance, let's change our existing formula to add $sign in front of rows and columns. Okay, and then I'm going to copy the cell and paste it. Okay, and this time the numbers copied exactly the same as it should have. Okay, so this is called absolute referencing. If you don't want the references to not change where you slide them to or where you copy and paste them to, then you need to use absolute referencing. Okay. So this, if I say C2 equals absolute value to column B, row 1, then if I copy this cell into other cells, then the value will not change. So you can try this yourself. Finally, references can be of mixed type, partly relative and partly absolute. So if the current cell is C5 and it contains the cell reference $B and no $6, then this references to an absolute column but a relative row. Okay, so this is an example, and let's try this. So get rid of this. So instead of adding a $sign next to the numbers, which are the rows, I am not going to do that. I copy this and paste it. It displays the same, but look what happens if I copy this and put it one below. The values have changed. Why? Because now it's referencing to the same column, C. This is fine. It's absolute referencing, which means it does not change. But the row values have changed from 1 to 10 to 2 to 11. So this means the rows are relative where columns are absolute. And the next thing is you can reference cells in one worksheet from a different worksheet. Okay, simply precede the cell reference with the name of the worksheet, e.g. sheet 1, exclamation mark, and then the reference to the cell. So if I want to reference B16 of the grades from sheet 1, I just type grades B equal sign equals grades B16, and it's going to give me the value that is associated in B16 from the grades worksheet, which is 76.4 copied into here. But since I have wider width, it's going to show me more digits. Okay, when you see a bunch of sharps, that means the cell is too narrow to display the value, which means you either have to reduce the decimal points or make the column wider. So I can reduce the decimal points to 2, which shows me 76.36, which is, oh, okay, I need to do one more, 76.4, which is equivalent to the value inside B16 inside the grades sheet. Okay. So if you want to know the names of the sheet, just look at the bottom of the Excel sheets. It will show you all the names there. Okay. If you want to reference a range of cells, you just have to use the colon separator for referencing the range of cells. So you have seen the examples in the means where I used A1 to A10 separated by column, which means it's going to select all the values included from A1 to A10. Okay? And this can be actually overlapped onto multiple columns as well. So for example, total average, here I can include average of all the columns and all the rows. So this is should start from 1. So this is selecting all the values that I have inside my spreadsheet, from A1 to C10, and this, if the formula allows multiple rows and multiple columns, then it will calculate. In this case, average do calculate multiple columns and multiple rows. Okay, so that is it for getting familiar with Excel. The next, we will look at some of the basics using formulas.